Hello and welcome to Tango Simulations. Today we'll have a look at several methods with which we can determine the target's heading. Method 1. Contact updates. Method 1 is really simple, and as the method title betrays, this is really useful if you're using contact updates. If you're playing without contact updates, which by the way are these magical ships moving on your map, the method is not going to be very useful to you. But if you're playing with contact updates, this is a really simple but at the same time really effective method. All you need to do is grab your ruler, okay? Then you want to go to the center of the ship, try to center it as much as possible. It can be a bit finicky sometimes. And then you want to draw a straight line towards where your target is moving. So I'm going to assume that the target is probably moving like this. For all intents and purposes, this is a good representation of the target's heading. And right now I'm playing with Mag UI, okay? And in Mag UI the helper tools are always enabled. If you're playing with the vanilla UI or some other UI where the helper tools are not available, you'll have to click the question mark button. On Mag UI, which is a UI that I really like, the helpers for the tools are on by default. At any rate, what you do after you draw this line, and you can see that there's just a little bit of a drift, so let's correct it. After you draw the line, you grab your helper tool, the crosshair, the middle of it, you put it on the target's track, and then you read the first bearing that the line intersects. So in this case, the first bearing that the line intersects is something like a 69. If you go to the right hand side and you read the second number, which is something like 248, let's say, that's incorrect. Why is it incorrect? Because we know for a fact that this guy is heading northeast, and 248 is not northeast. 248 is actually southwest. So really important. If the track was reversed, so ignore this ship and suppose that the target is here and he's heading towards here, okay? In that case, the bearing you would read would be 248. Why? Because again, we are reading the first bearing, not the second one. So if the target is moving right to left, we read the first bearing from the right. If the target is moving left to right, like he does right now, we read the first bearing from the left. Again, the first bearing from the left is either the 68 or the 69. It's a bit hard to see, but yeah, that's the methodology for method number 1. Really simple, really useful if you're playing with contact updates enabled. If you don't play with contact updates enabled, not that useful. Method 2. Visual estimation. The visual estimation method can be very easy and also very difficult. For example, if you manage to perfectly align your sub in a parallel course, you then know for a fact that the target is holding the same heading as you. However, perfectly matching his speed may prove problematic, either due to bad weather or because the target is reducing or increasing his speed throughout the journey. Where this method shines is if you manage to align yourself perfectly with either the target's stern or with his bow. In both cases, you'll be able to very easily calculate the target's heading, given that you have an extremely good idea on where the target's bow is pointing. So let's put this example in practice. What we're going to do is we're going to start sailing straight ahead so that we can set up on the stern of this medium cargo. Now, as you can see guys, we are almost directly behind his stern, but not quite yet, okay? Let's keep going 1/3 speed. Alright, around here I suppose. The bearing to the target is 70. We know for a fact that we're traveling due north, okay? So if we go ahead and draw up a compass, we are heading north, and we know for a fact that we have somebody on our 70 degrees, okay? And we have as close to a perfect 180 degrees angle on bow as possible. So therefore, what this means is that his bow is pointing around 70 degrees on the compass. Therefore, if I tell my crew to start sailing 70 degrees, 69 is good enough too. And then if I accelerate you guys will see that we are going to essentially set up on a parallel course. So right now the angle on bow is a bit weird, so it doesn't really look like it. But if we go on the map, you can clearly see that if I take a ruler and draw out our heading, and if I do the same thing with him, then if I take a protractor, you can see that we are almost at the perfect 90 degrees angle. Almost. And indeed, if we return back to the conic tower and I accelerate even more, eventually we are going to attain a perfect parallel course. Now at this point, if we don't slow down to match his speed, as you can see, angle on bow will change, and eventually what is going to happen is we are going to overtake him, right? But we are still, again, if you go back on the map, we are still on a parallel course. It's just that we are way faster than him. There's also a tiny bit of separation. This usually means that the heading is just a little bit different, so he might be heading 68 or 70, so there's just a bit of a difference in the heading, but in the grand scheme of things, and just calculating everything with your eyes without any complicated mathematics and stuff, pretty damn good. Now let's go ahead and do the exact same thing with his bow. So what I'm going to do, I'm going to turn right. Ideally, you want to form as much of a perfect T as possible. If your course is a little bit crooked like this or like this, you can still get a good result. But if your course is perfect and your course in combination with his form a perfect T, or as close to a perfect T as possible, it really helps make the calculation a lot easier. Okay, we are almost aligned with his bow. We're waiting just a little bit more. This time the alignment is almost perfect, so you'll see that at the moment where I have an angle on bow of 0, oops, I pressed the wrong button, sorry about that. I was about to say that by the time I have an angle on bow of 0, dead 0, he is on my 90 degrees. Obviously, I wasted time and now he's on my 91, which is pissing me off. But unfortunately, I pressed the wrong button. At any rate, let's assume for a moment that he is at a perfect 90 degrees. Okay. Again, let's go back to our compass, right? We know for a fact that we're heading 160. 160 is just shy of 180, so quite possibly something like this. And on our 90 degrees, we've got a target who is heading straight towards us. So if I was to draw a line that penetrates my sub and exits through the other side, you'll see that a perfect 90 degrees angle is created. So what I'm going to do is I'm going to do 160 minus 90 equals 70. And as you remember, guys, the previous heading we found was 70, so same result pretty much. So let's do the same thing again. Let's create some separation. And then I'm going to order my crew to sail 070.
Jawohl, Herr Kaloin. Neuer Kurs 70.
I heard the crew say 70, which means 70, but the text is reading 69. I call bullshit on that one. I really call bullshit on that one. But anyhow, let's go back to the map. You'll see our sub turning to get into the new course. And now let's stop the engines and see how much of a perfect parallel course we really have. So, just a little bit more. Stop the time here. Take out the protractor. And again, you can see almost a perfect 90 degrees. So, at this point, assuming I've got all the data I need, I'm ready to go full ahead or flank ahead to overtake the target. And then what I'm going to do is I'm going to turn into the target. you'll see right now that I am pretty much aligned with the target the way I'm supposed to. So almost perfect 90 degrees. My submarine keeps turning because for some reason the compass is not working as intended, and I don't understand why, to be honest. But yeah, if it stopped when I told it to stop, I would have a perfect 90 degrees angle. So as you can see, the visual estimation is a perfectly valid method, a perfectly valid choice, especially if you align yourself with the target's bow. And now let's look at the final method, which is the most complicated one. Method 3, multiple bearing plotting. Alright, first things first, I unselected the contact updates. This means that, as you can see on the map, we can't see any of the ships that are present, okay? So this is the hardcore way of doing this. Now, what is the multiple bearing method? The multiple bearing method, as the name suggests, is you taking or recording multiple different bearings in a very specific time interval. So you will take one bearing, you will wait for some time, that's very specific, then you will take the next bearing. You will do the same thing, very specific timing, until the next bearing, and until the next bearing, and until the next bearing, and in the end, you will have on your map various bearings plotted. Let's suppose that this is an example, right? And then you can draw a line through all the bearings, and then say that this ship, for example, is on a course of 050, okay? So it's essentially the first method I showed you, but without the magic ships on the map, okay? As I said, the interval you use for taking the bearings needs to be very specific. And personally, I suggest you use the 315 rule. Do you guys remember the 315 rule from my speed calculation video? I suggest you use the 315 rule because if you do so, not only are you going to learn the heading of the target, but you're also going to learn his speed. Now, this method can be executed underwater too, you don't have to be surfaced, and this is obviously very good for stealth, right? But keep in mind that for this method to work properly, you need to be moving less than 1 knot. If you can be completely stationary at 0 knots, that's the ideal thing, okay? Because the more you move, the more the bearing changes. And so if you mess with the bearings, the entire method is going to go to waste. So ideally, you want to wait for your speed to drop to 0, okay? So what's going to happen is I'm going to raise my periscope, okay? Let's work with a medium cargo that we worked before, because that way we have a very good idea of what his heading is. His heading is something like 69 or 70, so we need to sort of get close to that number, okay? I'm going to record the bearing to the target, and for consistency, I'm going to use his funnel every single time, okay? Or I could use his flag. Yeah, we're going to use the flagpole. And I'm also going to calculate the tick marks, okay? So that I can get a good reading on his range, okay? Then what I'm going to do is I'm going to hit the clock, and I'm going to wait for 3 minutes and 15 seconds, and then I'll take the next bearing. Wait another 3:15, take the next bearing. I'm going to do it 4 times, so I'm going to do the 4 bearing method. If you don't want to do the 4 bearing method, you can do 2 bearings, you can do 3 bearings, you can do even more than that. So, let's wait for his, let's wait for his flagpole to align with the 002 bearing. Hit the clock. And what about tick marks? I would say his 2.9 tick marks. So let's work with that. I know this ship is 25 meters long, so divided by 2.9 tick marks equals 8.6. 8.6 multiplied by 0.21 for the 6 times scope equals 1.8 kilometers. So we go on the map, okay, we pick up the compass tool, we bring it out to 1.8 kilometers, and then we align the line with the number 2 bearing, which is I think it's this one, unless I'm very much mistaken. So draw it out to 1.8 kilometers and stick with it. Put a marker down. remove the circle, and now we wait 3 minutes and 15 seconds to do the exact same thing again. Just before the clock runs out, I'll be calculating his bearing and also trying to see if there's any sort of change on the range. Obviously we know, because of the angle on bow, that this guy is moving away from us, so theoretically speaking, every single bearing we take should be just a little bit further than the last. So probably the next bearing is going to be 1.9 kilometers away, the next bearing is going to be 2 kilometers away, and the final bearing is probably going to be 2.1 kilometers away. We'll see. In terms of range, he might be doing 2.8 tick marks now, and I'm trying to anticipate his bearing. His bearing is probably going to be bearing 8. Yeah. So bearing 8 with 2.8 tick marks. So 25 divided by 2.8 equals 8.9 multiplied by 0.21 equals 1.86. 1.86 kilometers. So go back to the map. We now know that his bearing is the 8 bearing, and he's almost 1.9 kilometers away. So first of all, line up the bearing right here. We know it's almost 1.9, but not quite. So let's do something like this maybe. Alright, delete the circle, wait another 3 minutes and 15 seconds to get the next bearing. Again, I'm going to be using his flagpole, and I'm going to be trying to determine if the tick marks have changed. It looks like they have. It looks like the tick marks might this time be 2.5, but or maybe 2.6. I'm going to say 2.5. We still have a little bit of time though, so by the time we reach 3 minutes and 15 seconds, it might be lower than 2.5 tick marks. So I would say 2.4 tick marks, okay? Almost 3:15. His bearing looks to be 13. Oops, a bit late on the clock. Let's work with 13 and 2.4 tick marks. So 25 divided by 2.4 or 2.5. Let's do 2.5. 25 divided by 2.5 equals 10. Multiplied by 0.21, this gives us 2.1 kilometers. To tell you the truth, I think this is an error. I think the true range is 2 kilometers because his speed isn't changing, so his range should not be changing dramatically. So I think the correct distance is 2 kilometers, not 2.1. At any rate, we're working with bearing 13, so 11, 12, 13 right here, and we're looking for 2 kilometers. So something like this, quite possibly. Again, you can never be 100% sure unless you're cheating. Right? And then we're getting ready to get the final bearing. Okay, so let's have a look at the tick marks. It's almost 2 tick marks, possibly 2.3. And the bearing, it looks like it's going to be 18. So let's work with 18 and 2.3 tick marks. So 25 divided by 2.3 equals 10.8, so essentially an 11, although let's actually leave it there. Let's actually leave it as a 10.8. So 10.8 multiplied by 0.21 equals 2.2. Once again, I have doubts that it's 2.2. I can believe it's 2.1, maybe 2.1 plus a little bit more, but 2.2 seems a little bit too much. So yeah, I'm gonna roll with 2.1. So bearing 18. So that's here. 2.1 kilometers out. 2.1. Alright. Alright, so first and foremost, we now do the first method I showcased, where we try to align those bearings with a single line. As you can see, there's a small mistake with the third bearing. Apparently the range was a bit wrong, right? I believe this is a bearing that I said is probably 2 kilometers out. Chances are it was 1.9 kilometers out instead of 2. But the 3 bearings line up, so that's good enough. And if we read the bearing, it says that the target is doing 71. It's 1 degree more than what we estimated, so it doesn't seem all that bad. So let's see how well we align. There we are, ladies and gents, at the 270 bearing, which is 90 degrees on my left side. I've got a perfectly aligned medium cargo ship. What's more, if I reduced my speed and possibly tried to match it to his own, so now we are at 0 knots. Let's try moving at 4 knots.
Jawohl, Herr Kaloin. Derzeitige Fahrt 3 Knoten.
So 4 knots is a bit fast. I'm gonna order my crew to go at 2 knots. And let's see if we can maintain a parallel course with him. If we can, it means that his speed is either 2 knots or close to 2 knots. So let's speed up. Yeah, there we are. He stopped accelerating. So right now we're matching his speed almost perfectly. As you can see, the angle on bow is not changing. We can't see the front of his bridge. We can't see the rear of his bridge. And as an additional confirmation, I told you guys that if you use the 315 method, you will also be able to tell his speed. So let's grab a ruler, draw a line from Mark 1 to Mark 2 and see what the ruler says about his speed. Surprise, surprise! It says 0.2, which means that the target is moving 2 knots. If we take Mark 2 and Mark 3, it still says 2 knots. If we compare Mark 2 with Mark 3, it still says 0.2. So again, 2 knots. And if we take Mark 3 with Mark 4, it still says 0.2. So even if we did miss our timing with the clock just a little bit, ultimately it doesn't make any difference at all. Because 1, we were able to set a perfect parallel course with the target, and 2, we were able to accurately calculate his speed so that we can match it and keep observing him. When we are done the observations, I'm going to order full flank so I can overtake him. And because I know I'm on a parallel course with him, all I have to do is turn 90 degrees left. So if we go on the compass, I'm heading 70. If I turn 90 degrees left, which is 340, you will see that once the maneuver is over, if I stop and then I lie in wait, eventually the target is going to cross my bow and I will have a perfect straight shot. So let's accelerate time even more. UZO is here. I'm just going to leave it at 0 degrees. And would you look at that? At my 0 degrees, I've got a perfect starboard 90 degrees angle on bow. At this point, I can easily sink him, but it's something I'm planning to demonstrate on my straight shot video, which will come right after this one. Thank you very much for watching, and I hope this tutorial will prove useful to you. Tengu signing off. Good hunting.